have to recognize and continue to recognize that the Bay, our most important natural resource, affects everyone in Rhode Island.
In May of 1982, the city immediately began to plan and design a significant upgrade to the facility so that it would meet the standards of the Federal Clean Water Act.
The mission and the challenge was very clear.
What we do at Fields Point ultimately is to clean water. At the wastewater treatment facility, this is done in stages, and this process replicates Mother Nature.
In 1995, the Environmental Protection Agency cited the Narragansett Bay Commission as the finest, the #1 maintained and operated facility in the entire country. It's the Narragansett Bay Commission sentiment that to ensure the quality of the Upper Bay, that it's important to educate our children for the future. In 1979, the United States Environmental Protection Agency cited the Providence Sewer Treatment Plant as one of the worst polluters in the country. My agenda was to bring the Narragansett Bay Commission into a situation not only where we were in compliance, but we were on the cutting edge of technology and setting the standard and raising the bar for not only the Narragansett Bay Commission, but for the standard throughout the country.
The original reason for building the sewers was because in the 1850s there was a cholera epidemic, and that's a disease that is waterborne or water-related that causes people to run high fevers, and it can be very deadly, especially back in those days when they didn't have all the antibiotics, that we have today. Dr. Edwin Snow, who was the superintendent of health in the city of Providence, traced the origins of the cholera to the rivers that ran through the neighborhoods, and he determined that the only way to remove the problem was to get the waste away from the population centers. And so that's what caused the planning, construction, and design of the original sewers in the city of Providence.
Back then, there were 150,000 people in the city of Providence, but 300,000 horses. And with horses come horse manure that is often in the city streets. And when the rains would fall and the streets would flood, that water, if not collected and conveyed somewhere, would go into the local rivers. That's why they combined the sewers, put the sanitary waste with the storm waters to make combined sewers. And all that flow would be conveyed down to the wastewater treatment plant at Fields Point.
Eventually the plant became overwhelmed with the amount of waste it had to treat. And whenever you treat wastewater, you generate a material that's called sludge. Now we call it biosolids. And that was a product that they had to get rid of. They were just finding some place to dump it. At some point, they were just going to run out of places to take it to. They knew that in Europe, they were treating their waste rather than just dumping it into a water body. And what they did is they simply added chemicals to the sewage, which caused a lot of the solid material and what makes the sewage so offensive drop out of the water, so you have a clearer liquid on top. And they brought that technology back to Rhode Island, and they built a chemical precipitation plant here at Fields Point, and that was the first level of wastewater treatment ever achieved here in Rhode Island, and one of the few in the entire United States. And as the flows continued to increase down to the plant because of increased residential expansion and industrial expansion, they had more sludge that they had to get rid of. They ended up hauling that down further into the bay on barges, and they were dumping it off of Prudence Island, which caused problems even further down the bay. People begin to realize that there are problems with each step that you take, and you need to find better and better solutions to truly solve the problem as opposed to just moving the problem. Beginning in about the 1940s, nationally, people began to believe that they had solved the problem of sewage treatment in this country, and now they could move on to other things. So the 1940s, 1950s, 1960s, not a whole lot was done in terms of sewage treatment. And a lot of the plants that were originally built in the big cities just fell into disrepair. What Congress did is they passed the Federal Clean Water Act of 1972, which required all treatment facilities in the United States to meet secondary levels of treatment within a certain period of time. And they provided a significant amount of funding to make that happen. The city had to try to make some improvements to their facility. They were generally unsuccessful. Essentially, the state of disrepair it was in you simply could not put any flow through the plant. The water going out of the plant was worse than the water coming into the plant, if you can imagine that.
In 1979, I was elected to the Rhode Island House of Representatives, serving District 71, the community of North Providence. My first assignment by the Speaker of the House at that time was to serve as a commissioner at the newly formed Narragansett Bay Commission, a blue ribbon commission established by J. Joseph Garrahy, Governor of the State of Rhode Island, to examine how we can improve wastewater treatment in Providence or the greater Providence area. At that time, the Providence Wastewater Treatment Facility, or people used to refer to it as a sewer plant, was literally held together by chicken wire and duct tape, with city workers working in obvious unsanitary conditions. There was literally raw sewage all over the facility. At that time, the Environmental Protection Agency was fining the City of Providence $25,000 per day for every day that they violated their discharge permit. The Providence facility was cited as the second worst polluter in New England and one of the worst environmental polluters in the entire country.
In May of 1982, the Narragansett Bay Commission immediately began to plan and design a significant upgrade to the facility so that it would meet the standards of the Federal Clean Water Act. And by 1988, that entire plant was completely rehabilitated.
The mission and the challenge at that time was very clear.
Wastewater is composed of solid and semi-solid materials and dissolved solids that come from homes, businesses, industries, and that type of facility. What we do at Fields Point ultimately is to clean water. At the wastewater treatment facility, this is done in stages. Preliminary treatment, primary treatment, and secondary treatment are the three processes that we use to clean the water. Preliminary treatment starts with a very heavy material being removed from the waste stream and comes to the first part of the process. That process is called screening. The water travels through what look like jail bars spaced about 3/4 of an inch apart, and anything big enough to get trapped on the bars does. And that's where we get a lot of cloth products, paper products, sticks and stones and things that are in streets. That material is removed automatically, put into containers and taken to the landfill in Johnston. And we take roughly 1,000 tons of that material out of the waste stream every year. From that point, the water is pumped down Ernest Street to the treatment plant itself, and the second part of preliminary treatment, which is grit removal, takes place. Grit is very heavy, mostly inorganic material. They settle very readily through the water column. So as the water travels through these open tanks, the grit settles to the bottom of the tanks. That material is containerized, pumped out, and we separate the water and the solid and take the grit to the landfill. The solids that stay in suspension, which are mostly organic solids, flow to the next stage of treatment, primary treatment. Here we remove most of the organic material, and our business is called sludge. Sludge is material, mostly organic, that will settle in our tankage. The size of the tanks that we have at Fields Point are designed to detain the water about 1.5 hours to 2 hours so that sludge material will settle in the bottom of the tank. That sludge is collected along the bottom of the tank and pumped as a slurry, because it's very liquidy, solid material that we get out of the waste stream and pump it to our holding tanks called gravity thickeners. The second part of primary treatment is fats, oils, and grease removal. And that material, if not removed, would end up in the Providence River and upper Narragansett Bay as an oil sheen. And that material, because it's lighter than water, floats on the surface, and we have skimmer mechanisms that travel along the surface of the water, and we pump that material out. Now we start secondary treatment. Solids that weren't heavy enough to settle in the primary tanks, nor light enough to float on top of the primary tanks, stay in suspension. They overflow the primary tanks and are lifted by screw lift pumps up to the secondary treatment process, which has 2 stages to it. The first stage is aeration. The aeration system is an ecosystem. It's a biological reactor where microscopic organisms do most of the work in removing the organic compounds in the waste stream. They remove biochemical oxygen demand from the wastewater. If it were left unremoved and went into the Providence River, the sewage would have a demand for oxygen and take away usable oxygen from the fish and the plants. That's what makes it so dangerous and makes it a pollutant. The second thing that happens in the aeration tanks is the process called flocculation. Those very fine particles that wouldn't settle in the primary tanks go into the aeration tanks, and then in this very turbulent atmosphere, they stick to one another because they have a slime growth around them. And these almost microscopic pieces become larger in mass and heavier in mass. So the liquid sludge mass that is in the aeration tanks flows on to the final clarifiers, which is the second part of secondary treatment. And here, that heavier sludge now settles through the water column and leaves a clarified effluent behind. And the clarified effluent, although very clean looking, will travel on to the last stage of the treatment process, which is the disinfection process. The reason is the water is still laden with pathogenic bacteria. Those are disease-causing organisms for human beings and other warm-blooded animals, and shellfish and fish also. The last stage of treatment is to put bleach, which is sodium hypochlorite. We add that to the final effluent, and as it travels through a maze or a series of baffles, the chlorine mixes with the water and kills off the germs. In essence, we add chlorine or hypochlorite to disinfect, and we add another chemical called sodium bisulfite to the water to take out any excess chlorine, so that when the water leaves us and goes into the Providence River, it has virtually no chlorine in it. The whole process on an average day takes about 12 hours. And this process replicates Mother Nature. The same thing would happen in water bodies if given enough time, and that's why wastewater treatment plants are engineered and designed to do this natural phenomenon. That's what we do at Fields Point.
The Environmental Protection Agency in 1995 cited the Narragansett Bay Commission as the finest, the #1 maintained and operated facility in the entire country. I think that is truly an accomplishment. Just last year, we completed the first phase of our 3-phase program to deal with combined sewer overflow. The project was a $370 million project. It was done on time and on the budget. Truly an accomplishment.
What the original builders of the system did is they put relief points in the system throughout its entire length.
Within the sewer system, there were 65 points when the sewer system would overfill due to rain or snow melt. Instead of coming back onto the city streets and flooding the streets, the flow would go out into the local rivers via these combined sewer overflows.
That combined sewer overflow problem is what we're trying to address now with a fairly substantial program that we are just completing the first phase of.
As of November 2008, when the sewer system fills to capacity, instead of those CSOs discharging into the local rivers, those points discharge into 7 locations called drop shafts into